This video is going to be an introduction to logarithms. Recall that 2 to the 5th or 2 raised to the power of 5 is 2 times 2 times 2 times 2 times 2, where the 2 is called the base and where the 5 is called the exponent, index or power. Sometimes the whole expression is also called power, so don't get confused by that. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So 2 raised to the power of 5 equals 32. Let's say we don't know what the exponent is. Then we can write 2 raised to the power of x equals 32, right? Now, what is the value of x? How can we rearrange this equation to get x equals something? In other words, how can we isolate x? We know equations like x plus 1 equals 2. Here we subtract 1 from both sides and we get x equals 1, right? So subtraction helped us here to isolate the x, because subtraction is the opposite of addition. Or we know equations like x squared equals 9. Here we take the positive and the negative square root of 9. So we get x equals 3 and x equals negative 3. So taking the square root helped us to isolate the x, because taking the square root is the opposite of squaring. But how can we isolate the x here? We also need something here like subtracting or taking the square root to isolate the x. And that would be the logarithm, because the logarithm is the opposite of raising a number to the power of x. We write log base 2 of 32. So we get x equals 5 because 2 raised to the power of 5 equals 32. This is important now. The logarithm is the opposite of raising a number to the power of x. It is just another notation of 2 raised to the power of x equals 32. And it is the exponent. I highly recommend memorizing this. Let's do an alternative approach to explain the logarithm. The graph of the exponential function f of x equals 2 raised to the power of x looks like this. No horizontal line can be drawn that intersects this graph at more than one point. This means that the exponential function is a one-to-one function and has an inverse. Let's use our switch and solve strategy to find the inverse. In step 1, we replace f of x with y. In step 2, we swap x and y, so we get x equals 2 raised to the power of y. In step 3, we solve for y. But how can we do that? Not knowing how to do that indicates that we don't have a method for solving x equals 2 raised to the power of y for y. To isolate the exponent y, a new method called logarithm notation is needed. This notation gives us a way to name the inverse of f of x equals 2 raised to the power of x. Solving for y gives us log base 2 of x. And in the fourth step, we replace y with f of x. The inverse function of the exponential function with base b is called the logarithmic function with base b. So we can write the following for the definition of the logarithmic function. For x greater than 0, b greater than 0, and b not equal to 1, y equals log base b of x is equivalent to b raised to the power of y equals x. The function f of x equals log base b of x is the logarithmic function with base b. These two equations are equivalent. This is the logarithmic form, and this is the exponential form. Note that the logarithm y is the exponent, and b is the base. In the next video, we are going to change the form from logarithmic to exponential and from exponential to logarithmic. So stay tuned. And if you like my videos, like, share and subscribe. Thanks for watching and happy learning, everyone.